All right, this is question number 2 from the 2007 AP exam. What we have here is something we've seen before, water entering and leaking out of the tank. They just changed up the equations. On our graph, we can see f of x is water entering the tank, and then g of x is water leaking out of the tank. And that's a piecewise function for these two situations. So we start off pretty straightforward. How many gallons of water enter the tank between 0 and 7? So we're just looking at water entering the tank, and this is that accumulated rate. They have given us the rate at which water enters. So if we want the total amount, we want all of this area underneath f of x. So I'm going to go to my calculator. That's what this question is. Let's just run to our calculator. We're going to type that in. I'm just going to grab that and move it away. So in my calculator, I'm going to type in the equation 100x squared times sine of root of x. Get all of that. And just give me a minute. Okay, and I'm going to graph it, and sometimes it's a good idea to use what they've given us as our window, and we can make it look exactly like we have. So I've set my window from 0 to 7, from 0 to 2,500, and we can see this particular graph. Now we're going second function, calculate. We're going to do number 7, which is the integral, and punch in from 0 to 7 of that function. And it does the graph for me, 0 to 7, and we're going to get how much has been added. So this one does say to the nearest gallon. So I get 8,263.8. So 8,264 gallons have been added. Let's look at the same type in question B. Find the time intervals during which the amount of water in the tank is decreasing. So now we got to look at the graph and figure out, when is the water level actually going down? Well, this is more of just a quick read of the graph. So here's my graph again, and I'm looking at when does the water level decrease. Well, we can see a couple of points here. This point here that they actually give us in the question as 1.617, and we see this point here, and they give that as 5.076. So they give us those two time intervals, and what I want you to note is that the water level here, the rate at which it's leaving is above the rate at which it's decreasing. So from 0 to 1.617, there's more water leaking out than is being added. That line is above f of x. So at this point here, the water level is decreasing. Now, as we go all of a sudden at this point up to 3, we see that the water level entering is higher than the water level leaving, so now the water level is going up. But at 3, we jump up to here, and now at time equal to 3, the water level at the rate at which it's leaving is above the rate at which water is entering. So once again, from 3 to 5.076, the water rate at which it's leaking out is higher than the rate at which water is being added. So these are my two intervals at where the water level is decreasing. Okay, so now we just make a statement. It does say give reasons for your answer. So what we can do here is simply say at this point here during these intervals, G, I'm going to say G of t, that's the rate at which it's leaking out, is greater than f of t. And if we say that, we've justified it. That's the intervals at which the water leaking out is greater than the water being added. Now the big question here is question C. Okay. So let me just get rid of a few things so we can see our graph again. Okay, so here's my graph, and part C says at what time is the amount of water in the tank the greatest? When do we have the greatest amount of water in the tank? Okay, so this looks like it's a maximum question, but it's kind of hidden here. So if I think about the level of water here, when is it the greatest? So we just said that from 0, I'm going to draw my time interval here. And we've said here's time 0, and we'll make this time 7 hours. We just said from 0 to 1.617, we said that the water level is actually going down. So we'll say the rate at which the water is decreasing. So let's say here's water being added minus the water being leaked out. If we look at that, this is a negative. The whole number becomes negative. G of t was greater than f of t, so that whole number is negative. That means my water level, and let's just call that W. That'll be the level of water at any time. If that's negative, that means my water level is actually decreasing. Now I'm going to mark this other time interval. We'll mark at 3. And at 3, from 0 to 3, we see that f of t is actually bigger, so water is being added to the tank. That means my level of water will be going up. From 3 to this other time interval here, we said was 5.076. Once again, the water leaking out was bigger, so the water level will be going down. And now, again, it switches over, and from basically about 5 hours to 7 hours, the water coming into the tank is greater than the water leaking out, so my water level will be going up. So it does look, in terms of maximums and minimums, that I'm going to get a maximum level here. But we have to remember always in these cases, we're going to test 0, we're going to test 7 as well, just to make sure maybe it had more right at the end. We want to know when does it have the greatest amount. Okay, so let's slide this up and let's test some numbers. Well, now I'm really looking at that little equation that I wrote right here, right there. Okay, so the total level of water is going to be my 5,000, because it started with 5,000, plus whatever has happened to the water being added and subtracted. Well, that's kind of odd because it's actually an integral. And I'm going to take this integral from 0 to whatever time we're looking for. So we'll say, I'll put x here, of f of t minus g of t. That becomes our interval. And even that could change depending on the time that we're looking at. Well, I want to test 0. So let's look at W at 0. Well, if we go from, let me show you here, if I go from 0 to 0, we've seen that where the integral, where both the endpoints are the same. Well, nothing has happened there. We haven't added or subtracted any water, so that whole thing just becomes 5,000. All right, let's look at 3. So I have my 5,000 plus, I'm going to go 0 to 3 of all of this. Now at 3, I have to just take a peek at what my equation is going to be. So I'm going to put in that t squared sine root t. Now up to 3, g is just 250. So I'm going to have to do all of this on my calculator? Well, I already have this in my calculator, so I'm just going to go back to y1, and I'm going to put in, right at the end, I'm going to put in minus 250. So I'm just going to change my equation a little bit, minus 250. It gives me a little different shape for my graph. That's okay. And I'm going to take this from 0 to 3. When I do that, this whole bit becomes let's wait for it. Here it comes. 126.5908. So altogether, let me slide this up just a bit. Altogether, the total amount of water in the tank at 3 hours, 5,126.59 gallons. Okay, so let's move on now, and we'll wrap this up looking at W of 7, the water level at 7 hours. Well, we got to make a couple of changes here because we can't really go from 0 to 7 because that G value kind of switches over at 3 hours. So now I'm going to just leave a space for a minute. My integral, I got to look at what is happening from 3 to 7. And f of t does not change. So that's still my, all of this root t. But my g now becomes minus 2,000 in this interval from 3 to 7. Now, what did we add, though? This is the big part here to remember. We can't start with 5,000 because we're only going from the interval from 3 to 7. So at 3 hours, we actually have what we just figured out. We have 5,126.59. Now let's go ahead and calculate how much did we add on or lose after this 3 hours, so in the next 4 hours here. So I'm going into my calculator and I'm punching in that equation minus 2,000, and I'm going to take the integral, so number 7, from 3 to 7 hours. While that's working its way through that, I'm going to just scroll that up. So this whole second part here actually becomes a negative 612.7843. So we've lost water over that last 4 hours. So I'm going to go ahead and do that. In fact, I probably don't even have to do the subtraction. Clearly, if we're subtracting water, then this is going to drop below the 5,126. It's going to go lower, so we can stop at that point and say our maximum will occur. I'll say max water level will be, I'm going to give this 5,127, we'll round that off because again it said to the nearest gallon, so 27 gallons at time equal to 3 hours. And we can make that statement. Okay, so the little switch there for number 7, you can scroll back and read through that one more time if you have to, but that's how we're going to solve that question.